welcome to everybody that is here. We had 155 people registered and we've got 88 people, so that's quite a large attrition rate. Maybe a few people are a little bit late and will join us during the talk. So my name's Wendy Humphreys. Most people know me. This is our last branch social event for our current season. Our season goes from September to April. So welcome to everybody who has turned up. The presentation tonight will be by Bowman Bradley, whose picture you can see on the screen. Bowman has asked Malcolm Bridge and Jonathan Moss to join us as panelists because they might be able to answer some of the questions. So welcome to Malcolm and Jonathan and Bowman. Malcolm is known to us. Malcolm came talk to us about his boat not ever so long ago, but he is known to us for other things. And Jonathan spoke to us at our last meeting. So without further ado then, I'll introduce Bowman Bradley, who is coming to talk to us about sustainable propulsion. There you go.
Okay, good evening, everybody. Well, thank you very much for coming to listen. We're over into the 3-figure mark now, so I'm very, very flattered. I often use this picture as a sort of starting point for canal presentations. It's one I took, and I can't even remember where I took it. But I think this absolutely sums up why we're all here, really. This is an English canal on a beautiful summer's evening. What could be nicer? We're going to talk tonight about sustainable propulsion. That is me, but I'm not alone in this endeavour. The Sustainable Propulsion Group, or as we're now calling ourselves the Sustainable Boating Group, we formed in March 2020. There's a list of the people who are on the group. You'll see Jonathan and Malcolm's names there. I'm not going to go through all those in detail, but the reason I put those up is just to demonstrate that there is a lot of excellent knowledge and experience within this group. Not only are there quite a few fairly well qualified engineering type people who do know their way around not only narrowboats, but also other bits of engineering, but between us, we own boats, and we've got a range of boats, and you'll see 3 of them on the right. And the top one's Malcolm's, which is an electric boat, which I think you're probably already familiar with. The bottom one is Rupert Smedley's 1930s working boat, which we'll meet again later. And the middle one is my boring 57-foot leisure boat of relatively modern construction. What it means is that between us and even the other people on that panel have got a fair amount of experience in the boating area. So that's who the group is. So what are we trying to do? Well, when we set up ourselves up in 2020, what we wanted to do was what it says there, to develop a vision of how the inland waterways might become sustainable. Why did we want to do that? Well, there's a lot of stakeholders in the inland waterways. I've illustrated some of them on the right, a massive range of people who've got an interest in the inland waterways in one way or another. However we propel our boats in the future when we can't use diesel, all of those people are going to have to adjust what they do to match whatever the new world turns out to be. And every one of them will have to make an investment of some sort or another. Some will be large, some will be small, in changing what they do to reflect the new reality. So what we tried to do was to put up a vision that said, this is how we see that the inland waterways might end up without diesel. And that will allow people to either say this is a lot of rubbish and this is a much better way of doing it, which is fine, or to say, well, that looks reasonable, this is the bit that I might be able to contribute to. And that's the biggest thing we've been doing over the past year. And in September, we published a vision paper, which is available. I think it's on the IWO website, but it's been to many people now, including Her Majesty's government, who received it quite pleasantly, to be honest. The other thing we're doing is monitoring and encouraging the development of technologies, because we recognise that all the technologies that we might use in the future, and I'm sure this is going to come up in some of the questions, they're going to change as time's gone by. In fact, they've changed in the time that we've been doing this. And they may change in ways that we don't envisage. Perhaps what we're suggesting might happen will be totally overtaken by something that nobody's thought of. So we are encouraging the development of technologies, but we're also monitoring them. We are not selling technology. We are not a commercial organization. We're not advocating this technology or that technology, but we're keeping an eye on developments and seeing whether they can help. And we decided right at the beginning that we were not blue sky thinkers. Well, maybe we are, but for this purpose, we're not. So we decided what we would do was to focus on technologies that either were available or very soon will be. And yes, there are a lot of things that might happen that we might have guessed about or we may not have foreseen, but we've tried to make what our vision based on practical available technology. The other thing we've needed to do is to look at the existing fleet and how we can mitigate the environmental impact of that, because it's large and it's going to be around a long time. And we'll be talking about that later. And this is really what we're doing now. And this presentation is about doing this. We want to encourage more sustainable boating by a range of publicity and educational activities. And this is one. So that's what we've been trying to do over the past year and a bit. It's nearly a year and a half now, isn't it? Yeah. So that's our objectives. So there are a lot of stakeholders, as I said, in the inland waterways. And, you know, you think of people associated with boats, which are the people I put up previously, but there's a lot of other stakeholders as well in the canals. Fishermen, we all know and love them. Walkers, cyclists, children and parents, and the retired. All these people use the canals, even if they're not boaters, and the majority of these people are not. Even they still use the canals, they're still stakeholders in the canals, and they still want to be part of the canal world, thank goodness. So, how do you propel a narrowboat? Well, I've actually done a presentation on this, but I'm not going to do the whole thing here. Well, there's one way. It has been suggested that maybe we should revert to that. So that's how it all started. And in fact, Roger Culbert was kind enough to send in a couple of photographs taken, I believe, by his father. There's another way of propelling a narrowboat in the 1950s on the Llangollen Canal. And there's another way. All fairly environmentally friendly, but probably are not going to work in the 21st century. But thank you, Roger, for those photographs. They've added a little bit, I think, to my presentation, hopefully anyway. Then somebody came along with a better idea. I'm sure a lot of people watching this today will know that boat. It's President. It lives most of its time at the Black Country Living Museum. It appears at many of the Waterways events around the country. It's one of fellow Morton Clayton's fleet of boats in around about 1910, if I remember rightly. And somebody came up with a better idea than a horse. It was a steam engine, coal-fired. There it is. That's the engine that's in President. And that boat, as I've just said, is still around. And that engine is still going. I don't know when everyone remembers the Queen's Jubilee pageant on the Thames. I think it was in 2012. There's President in that pageant. That was taken by a friend of mine who was in a narrowboat behind it. The BBC didn't think it worth showing, but there it is going down the Thames in the Queen's Jubilee pageant. Then somebody came up with an even better idea, and this is Rupert's boat Skylark, built in, I think, around about 1930 to carry chemicals around the Manchester area. Still got its original engine. There it is. It's a Gardner semi-diesel, still going strong. And actually, what's quite interesting, and we'll reflect on this in a bit more detail later, I think I'm right in saying that boat uses about the same diesel in an hour as my modern leisure boat with an Isuzu modern sophisticated engine in it. And we might want to reflect on why that is. And that's doing it with a 1930s single-cylinder semi-diesel engine. And of course, at the same time, the well-known Bowlinder came along. So boats started to be driven by diesel engines, and they got more sophisticated as time went by. There's what I think, some will no doubt tell me I'm wrong, I think that's a 2-cylinder Lister, in probably a fairly modern boat, but in a traditional engine room. So that was how the propelling of narrowboats progressed. Then, of course, there's my modern leisure boat with the ubiquitous 4-cylinder modern diesel engine in it. This happens to be an Isuzu, other diesel engines are available. So that's how we do it now. And I would think the vast majority of boats on the canal system now are engined in somewhat in that way. Now, if somebody said, come on, Bowman, all you want to talk about is 57-foot narrowboat. So let's just look at some of the different boats that are kicking around the canals. Mostly they're driven by diesel, but there's a little higher boat. That's Jack, the 33-foot higher boat from the Midlands. That's got the advantage it can turn around on the canals. And there's Alison Smedley's tug Sandbach, also with a very old traditional engine in it. It's got a Bowlinder engine in it. Still going strong, built in 1946 in Northwich for the London, Midland and Scottish Railway. Beautiful boat, absolutely beautiful boat. And there is the Sea Otter, Trailable narrowboat. 21 feet, I think. There's something a bit more traditional, a wooden boat off the Weaver, Jacqueline, classic wooden Weaver cruiser boat. And here's something you'll often see on the canal. That's the CRT workboat Churnet at Alderham, parked doing nothing. I'm sure that's a rare thing, but you know, they're another type of boat, also diesel driven. Now there's something a little bit more ambitious. Got a couple of twin Volvo Penta 160 horsepower engines in it. I don't think you get that very far with that on a battery, but there we go. And of course, we've seen many of those, the Norman 20-foot cabin cruiser, but surprisingly large numbers still around on the canals. So there's some different sorts of boats. So what about the future without diesel? So do we want to go back to a horse-drawn boat? Or do we need boats at all, one might ask? Well, I would suggest that we do. This picture was taken in 1961 on the Stourbridge Canal. That's what happens to canals if we don't have boats on them. I don't think we want to see that. I don't think boaters want to see that. I don't think other users of canals want to see that. The boats on canals are an important and vibrant part of the canal scene. Without boats, I think canals will die. And the Inland Waterways was set up in 1948 to prevent that happening. And I think we've got an equal obligation today to try and make sure it doesn't happen again. So if we want to make canals sustainable, if we want to keep boats moving, what are the problems that we need to solve? Well, the first one is, what would a boat look like if we were going to build a new boat today and make it sustainable? What would a new build boat look like? There's an electric boat called Shine. It's got a lot of solar cells on the top. Who knows what part that might play in what we do in the future? So how we build a boat today is an important question. To be honest, the more important and more urgent question is the existing fleet. There's something like 80,000 powered boats on the Inland Waterway system. Most of them are diesel powered. Not all of them, most of them. And they're going to be around a long time. So we need to think about what we do about them. And finally, we've got to think about however we drive our boats in the future, how we're going to refuel them or recharge them. At the moment, we use something that looks a lot like a petrol pump. Obviously, if we want battery-powered boats, we're going to need charging sets alongside the canals. And even if we go to hydrogen, then we still need somewhere we can fill our boats up. So those are the three problems, and I'm going to look at each of those three problems in turn. Oh, sorry, there is a fourth problem, and we must not forget it. And this is the reason that we changed our name to the Sustainable Boating Group, because there are other issues around the canals that have not got to do with propulsion, environmental issues. To make the canals truly sustainable, we've got to think about those as well. And so let's look at each of those things in turn. The future narrowboat, what will it look like? Well, it's almost certainly going to be powered by an electric motor. It's almost certainly going to have a battery. It has to be designed for flexibility, and we'll look at the reasons for that in a minute. I don't think there is one single solution to this problem for a new build boat. We think ultimately it'll be equipped with a hydrogen tank and a fuel cell. Now, that ain't going to happen next week or next year, but we think that is the ultimate solution. You will be able to charge that new build boat with a shore connection, with photovoltaic cells, forgive me, or with the fuel cell. In the short term, and we'll look at this again a bit later, we can use a small diesel generator instead of the fuel cell. Now, you might say, well, how does that help? But it does, in fact, help. It rather helps more than you might expect, actually. And we are aware that there are dual fuel cells around. They're not as well developed as a hydrogen cell, but there are fuel cells around that could run on hydrogen or hydrocarbons. So you could imagine putting a fuel cell in that would initially run on a hydrocarbon like propane, and maybe later when hydrogen becomes available can run on hydrogen. Those are not as well developed, but I believe that Toyota have built a car running on that type of fuel cell. Now, the interesting thing is all the technologies I've talked about very briefly there, they all exist and they're all being developed in other fields of transport. And they're all being developed at a scale which is entirely appropriate for narrowboats. Our requirements, our power requirements, are well within the technologies that are being developed. So that is what we see as the future narrowboat. It's okay. It's been done before. The Ross Barlow, there it is. It's not very pretty, but it was built by Birmingham University in 2007. It's powered by hydrogen. Didn't mean to tell you that yet. It's powered by hydrogen. Built by Birmingham University as an experimental boat in 2007. And the interesting thing is, it's not very, very different to our narrowboat of the future. In fact, it's remarkably similar, except for one thing. All the technologies that are being used on that boat have been developed a great deal since 2007. But there's a flow diagram of that boat when it was built. I'm not going to take you through this in a lot of detail, but basically you've got hydrogen, you've got a fuel cell, you've got a battery, you've got a motor, and you've got other ways of charging the battery. And that is very much like the boat we envisage that we're going to be using in the future. But every one of these technologies has developed dramatically since 2007, largely because they've had to be developed for things like road transport. So, the electric boat. What does the electric boat look like? Well, it's got to have a propeller. There's your start. That's what we're trying to do. We're trying to turn that round. So it'll be driven by an electric motor. And since the days of Ross Barlow, electric motors have come on a great deal. They're much more sophisticated, they're much more efficient, they're much more controllable. So, of course, you need a bunch of electronics to drive them. You can't just connect them to a battery in the way that you used to. You do have a battery. That, in fact, is a lithium-ion battery, much as you might find in a Nissan Leaf, but on a narrowboat, there is really no reason why you can't use lead-acid batteries and other types, which are, of course, quite a bit cheaper. And the real problem that you've got now is how do you charge that battery? Because if you can charge that battery, you've solved the problem. Well, there's a number of different ways you can do it. And we see that the narrowboat of the future will use all of them. You can plug it into shore power. My boat at the moment has been sitting in a marina for the last few months. If I had a setup like this, and I went to it this weekend, which I might well do, I'd find that battery fully charged and maybe I could go off for half a day or a day and do a bit of cruising. So it's an option. If I can find somewhere to plug it in when I stop at night, that's what I can do. I can put photovoltaic cells on the boat. Now, a narrowboat, as it turns out, as is totally obvious to all of us who know them, they're actually very, very well designed to take photovoltaic cells. Unlike, say, a car, you can put quite a lot of photovoltaic cells on the top of a boat. To be perfectly honest, particularly in the UK, we don't see that as providing all the power that the boat needs, but it can make a contribution. It can make your battery last longer than if you didn't have them. So photovoltaic cells have a part to play. So what do you do when you can't find somewhere to plug in? Well, at the moment, you can put a small generator on to charge that battery. Now you might say, well, how does that help? Because you're still using diesel, which is true. And why is that a better setup than my boat with its 2-litre 43 horsepower diesel engine? Well, you will find that setup will give you much better fuel consumption than my boat can achieve. And we'll come to the reasons of that in a minute. But the other thing is that generator, one day, hopefully not in the not too distant future, can be replaced by a fuel cell. Might be a dual fuel cell that can run on hydrocarbon and hydrogen, or it might be a hydrogen fuel cell. Now, if you had an electric generator and you put a fuel cell in, it's going to cost you. There will be money involved, but it's not as expensive as, say, converting my boat to all of this. So that generator is a halfway house. So that's what we see the electric boat is looking at. And there's Malcolm's boat Ampere, which is very much like that with the generator rather than a fuel cell. And Malcolm will tell you, and he will tell you if you ask him later, that his boat will save between half and 2/3 of the fuel that my boat uses, because an electric boat, when the prop's not turning, no power is being used. Whereas I think we are all guilty of stopping to wait for a lock or stopping in a lock and leaving the engine idling. So a bit like stop-start technology on a car, that's quite a significant power saving. The small diesel generator can run all the time. You don't just run it when you want to turn the propeller. You can run it continuously near its most efficient duty point. So it is going to be inherently more efficient than my 2-litre 4-pot diesel in the back of my boat. And it is true, I don't want to go into this in too much detail unless anybody wants to later, but with careful design, an electric motor can use a larger and hence more efficient propeller than the conventional diesel engine. So for those reasons, you can get an awful lot better fuel consumption out of an electric boat like Malcolm's you can out of a conventional boat like mine. And that is actually the reason why Rupert's 1930s boat uses the same fuel as mine. The engine isn't so efficient, but it's got a big propeller on it because it has a deep draft. And therefore the inherent efficiency of the propeller is better. So there's the technical details behind Ampere. I will not take you through them in detail, but here you can see a little generator in the front, some reasonably conventional lead acid batteries, and a quite sophisticated motor. Malcolm will talk about this in a lot more detail later if you would like him to. But as with my big diesel engine, this generator can also provide hot water and underfloor heating and stuff like that. So you can get a bit back that way. So that's the electric boat. So everyone says that we call that the electric boat. What about hybrids? Well, there's what we call the parallel hybrid. You can buy this engine today, and there's quite a few canal boats fitted with it. On the back, it has a motor generator sitting there. And that can be used either as a motor to turn the propeller when the diesel is not being used, or when the diesel is being used, it can be used as a generator to charge the battery. Just like with the road car, that will give you probably a better fuel consumption than the plain diesel engine. But obviously you cannot get away totally from diesel in a setup like that. So yes, it works. It provides better fuel consumption. We don't see it as a long-term solution anymore, I think, than it's a long-term solution for road vehicles. But it's there and it works, and you can buy it today. So we've talked about a hydrogen fuel cell, and everyone says, well, where are you going to get your hydrogen from? And it's a very, very good question. But there's a lot of hydrogen stuff around. Hyundai have, back in 2020, announced a hydrogen power excavator. That is a hydrogen powered ferry boat in Bristol Harbour. That's a hydrogen bus in Aberdeen. That's a Cummins truck in the States, so it says Cummins on the back, driven by hydrogen. That is a train developed by Alstom for the UK rail system. They're already running them in Germany, hydrogen-powered trains, and they look as though they're going to be economic, where it's not worth spending the money on electrification. And Birmingham University is also building a train of that sort, has built a train of that sort, running on hydrogen. There's a hydrogen-powered forklift truck. So where do we get the hydrogen from? Good question. There are two ways of producing hydrogen. One is by electrolysis, but you need electricity, of course, to do that. And the other way is by steam cracking natural gas. Well, how does that help, you might ask? Because you're still using natural gas, which is true. But as an interim solution, it's probably the only way that as a country we can produce enough hydrogen to replace natural gas. But of course, the only way that becomes semi-green is if you can capture the CO2 that process produces. And this is what is known as the Northwest Hydrogen Hub. There are probably half a dozen of these planned for the country. There is one in the northwest of England, which is near to you, that is being developed. And the idea is that you produce hydrogen here in quantity. Because you've got a big plant here and it's all happening in one place, you capture the CO2, and you put it back down redundant gas and oil wells, and there are quite a few off the coast here, of course. And then you distribute the hydrogen. You distribute it to large users to generate power for industry. You send it to homes, because, by the way, you put 20% hydrogen into the natural gas network and you would never know. Your central heating boiler and your cooker will run quite happily. It can also be used for transport, for trains. Admittedly, you have to purify it and pressurize it, but that can be done locally up here. So this is the sort of picture that the UK government has got for our hydrogen future. And it's not that hard to imagine that once you're producing hydrogen for trains and cars, you could do it for canal boats as well. But the problem is, of course, an infrastructure, and we'll come to that. So that's one place hydrogen might come from. Now, obviously, offshore wind farms like this can produce hydrogen by electrolysis at night when we don't need the electricity they produce, and that's being looked at as well. So another solution for hydrogen is that. And there's a lot of developments coming along. This is starting to be a bit blue sky, but let's have a look. These are the solid oxide fuel cells that can run on either hydrogen or hydrocarbon. And there's a lot of stuff there that tells you that they do work, they can work. They're not as readily available yet as a pure hydrogen cell, but who knows what's just around the corner. There are alternatives to batteries. We know the problems with batteries, charging them up, the time it takes. Things like supercapacitors will work better than batteries. They can be charged faster. They're on the horizon. Tesla have just bought a company that is developing this technology. So that technology is going to come along and make batteries more practical for not only for canal boats, of course, but also for road transport in the future. And even conventional batteries are being improved every day in the road transport field, but we can live on the back of that. That was an announcement in March 2020. Not only will batteries be able to be charged faster, but they'll have a bigger range. So battery technology is going to develop, and hydrogen storage is going to develop. At the moment, there are many hydrogen cars in the world. There's tens of thousands, actually, mainly in California and Japan, and they use high-pressure hydrogen tanks. But there are other ways of storing hydrogen, and this is one of them. And this is being developed as well. And in fact, Ross Barlow used an early version of this technology to store the hydrogen in the Ross Barlow canal boat. And of course, PV cells are going to continue to develop. They are getting better. To be honest, I'm not sure they will ever get good enough in the UK to 100% power a canal boat. But as they get better, they can make a bigger contribution. So that's the new build. That's what we see as the future new build boat. But what do we do about the existing fleet? It's large. It'll be with us for some time. My boat's 15 years old, 16, I think. It's barely run in. Rupert's boat there, built in the 1930s, still going strong with the same engine. Boats last a long time, not like motor cars that disappear in a few years. So we can't just ignore them. We can't just ignore the existing fleet. We've got to do something about it. So why don't we use biodiesel? Well, there are a number of reasons. And the reasons are the same reasons as all our lorries and cars are not running around on biodiesel. There is a first generation biodiesel, which we call FAME biodiesel, and it's currently being added to road fuel and to red diesel as it happens. So you've got some in your boat at 7%. It's known as B7 diesel. The government is encouraging this because it reduces the use of fossil fuels. And so why do we only use B7? Why don't we use 100%? Well, it's produced by the transesterification of vegetable oils. Won't go into what that means, though I did work for a couple of years in this particular field. But it's got some problems if you use it, particularly at 100% in a marine environment. Firstly, some of the older engines need modification because that biodiesel will eat some seals, some rubber seals and pipes. So it's not massive, but it does need some work. It's, depending on what vegetable oil it's made from, it can be absolute rubbish at low temperature. If you've ever put any olive oil in the fridge and seen it go solid or semi-solid, you'll know what I mean. Depending on the type of oil it's made from, it can perform very, very badly at low temperatures. And low temperatures means below 20 degrees C. So it's great stuff in the tropics. It's not so good in Northern Europe. We all know about diesel absorbing water in fuel tanks over the winter. Biodiesel is much worse. It has a much bigger problem with water retention. And we have discovered, or at least the Canal and River Rescue have discovered, clogging of filters and injectors after periods of inactivity. And obviously there's been a lot of boats that have been sitting around for a long time in the last year. And they've got increasing problems with boaters trying to start their engines and finding that their injectors and filters and pumps to some extent are clogged up. And it's due to, we think, it's due to several things. Probably the biggest one is glycerol still left in the biodiesel, which is settling out. I was very pleased to say I started my boat after 6 months of inactivity last week and it ran beautifully. So I'm very pleased about that. And of course, with biodiesel, sustainability of raw materials is a problem because it's made from vegetable oil. You can make it from almost any vegetable oil, including recycled cooking oil, by the way. But it is a vegetable oil. And if you're growing vegetable oil to make biodiesel, you can't use that land to grow food. You might even be directly taking from the world's food supply. So that is an issue, sustainability of raw materials, which really means that we will never be able to produce enough biodiesel to replace mineral diesel in all the forms of transport and other things that we use it in. So that is an issue. So there is another form of biodiesel or biofuel called hydrotreated vegetable oil. And Jonathan will tell us a lot about this if anyone has any questions afterwards. We know it as HVO. Forgive me, I need a drink of water. We know it as HVO. It's a second generation biodiesel. It's made by a different process. It is produced from vegetable oils, as indeed first generation is, often waste oils. It can use cooking oils from all over the place, and it uses hydrogen. So obviously you've got to make sure the hydrogen is green as well. But okay, that's a bigger problem. It has none of the technical problems associated with FAME biodiesel. None of them. It's been accredited for use in all modern canal boat engines, and Jonathan has done a great deal of work to pull that information together. The IWA has done successful trials in a lot of canal boat heaters and cookers that we all use, run by diesel. They've run beautifully on it. We are going to do some trials on traditional canal engines. We haven't been able to do them because boats haven't been moving around, and when boats are not moving around, it's very difficult to do propulsion trials, but those are planned. But certainly all the modern canal boat engine manufacturers or converters, they are quite happy for HVO to be used in their engines. Ampere's generator, as far as I know, is currently running quite happily on it. It's becoming increasingly available. It's in use on the Thames commercially, and we are in regular contact with the tugboat fleet on the Thames that's using it. And the same source is making it available on the Lee and Stort to sell to Narrowboats. So it's becoming available. It is a little bit more expensive than mineral diesel, about 10p a litre, which is quite an issue. If you're in a commercial world, it may or may not be less of an issue for leisure boaters, but the IWA is campaigning to try and get that put right by tax adjustments. So we see HVO as probably the solution for the existing fleet. It still has a problem, and that's sustainability of the raw materials. It still requires the use of vegetable oil. So why can we justify using it on the canals? Well, it is an instant solution to an environmental problem. The usage of diesel on the canals, in the big picture, is quite small. Our engines are relatively small, and it's a fairly small user of diesel. So it may be morally justifiable to use it, even though it uses or can use food oils. It is currently being made entirely from recycled cooking oil and similar materials, so that helps. But also it's a diminishing issue because as time goes by and the traditional fleet reduces in size, the use of HVO will reduce as well. So on that basis, we think a case can be made for using HVO on the inland waterway system. So there we go. There's a couple of solutions. We've got a solution for future boats and we've got a solution for the existing fleet. But we still haven't solved the problem of how you recharge or refuel the new world. Now, if we're using HVO, we can use the existing infrastructure for the existing fleet. There is absolutely no reason why your marina or your boatyard can't fill its diesel tank up with HVO and sell you HVO in the same way as it sells you mineral diesel. There's absolutely no problem in doing that. So from that point of view, tick, that problem solved. If we want to go electric, then we are going to need bankside charging stations. Yes, we can charge our boats in marinas if we're not using them. We have to charge them at the moment relatively slowly. But if we want to use electric boats all the way around the system, the charging time and the range of those boats are not what we would want them to be. So there is going to be needed, at the very least, a fairly substantial infrastructure of recharging points. And as somebody has already asked me before the meeting, obviously, when you get out in the country or you get away from what you might call the heart of the system, providing that infrastructure will be more and more expensive. And of course, charging a boat up at the moment with the current technology takes time. Let me just see how we're doing on time. I need to get on. Hydrogen is much better. We can refuel quickly. We can carry enough hydrogen so the range is acceptable, but we still need a distribution infrastructure and we need the hydrogen to put in it. And of course, recharging and refueling is a chicken and egg situation because nobody's going to buy a hydrogen boat until there's a hydrogen infrastructure, and nobody's going to build a hydrogen infrastructure until there are hydrogen boats to use it. So that's the problem. We can talk about that later if you wish, but I'm going to move rapidly on. Non-propulsion issues, we've only just started to think about those, but they are important. We can all help by behaving a bit better and not running engines unnecessarily when we're cruising. As I say, we've all waited for a lock with the engine running all the way. Going too fast. One of the ways you can save a great deal of fuel is by not trying to go too fast, because you probably won't go any faster anyway, just use fuel. Dredging of canals can save fuel. Obviously, there is a cost to the dredging, but the IWA is trying to persuade the Canal River Trust to do more dredging, because that way the system will use less fuel. There is a problem in the use of hydrocarbon and solid fuel for domestic purposes, particularly in the larger cities. And there are environmental issues associated with boats being used primarily as domestic accommodation. And that is largely a city problem as well, where people live on boats in London because it is relatively cheap. So those are the non-propulsion issues, and we haven't picked those up dramatically yet, but we are starting to think about them. So let's just run you through a few recent developments that have happened in the last few months. We are starting to interact with quite a lot of stakeholders. The government, we made a presentation to the all-party parliamentary group for the Waterways in November, and quite a lot of MPs have heard much of the stuff you've heard tonight. We made a submission to the Environment Bill consultation. We made a submission to DEFRA's Inland Waterways Policy Team. We made a submission to their Clean Air Charter team, and we're currently in the middle of making a submission to the Department of Transport's Renewable Transport Fuel Obligation consultation, which, as far as we're concerned, is going to be largely about trying to get the tax system adjusted so that HVO will not cost any more than mineral diesel. The Canal and River Trust have taken on board what we've said. We had a very promising meeting with them a few weeks ago, and they're about to publish their sustainable boating position paper. And they said to us that our paper has supported their thinking, or rather, their thinking is very much along the lines of our suggestions and recommendations. So that is exactly what we wanted our vision to do, to get people like the Canal and River Trust to say, we can see where we can fit into this. The boat safety scheme are starting to look at future propulsion methods. Again, taking our vision as part of the guidance for what they do. And we're starting to engage with academia. Strathclyde University, Warwick University, and Durham universities are all interested in sustainable propulsion. Who knows what can come out of that? We have a biofuel subgroup, admirably led by Jonathan, that's looked at fuels, set up in January this year. That it is part of the Sustainable Boating Group, it's a subgroup, and there's a heck of a lot of accumulation of knowledge and experience on that group around the chemistry of fuels and the use of fuels. And it's identified HVO and conducting trials with it and encouraging suppliers, and there's at least 2 suppliers in the UK, we'd like to see more, encouraging them to make it available on the inland waterways. They have established that HVO can be accredited in modern canal boat engines, and it's now promoting and supporting its use. It's working with major commercial boat operators, both on the canals and on the Thames, and the Commercial Boat Operators Association on the use of HVO, and they are finding it very satisfactory in their admittedly larger engines. As I've already said, we're contributing to the low carbon fuel consultation, and HVO is now available on the Thames and the Lee and Stort. And we're encouraging the use of HVO at the 2021 Waterways Festival and by the Waterways Recovery Group. So congratulations to that subgroup. They're starting to push HVO along. You may have seen some media coverage recently, which we have had our hands in. Waterways magazine has had several articles. Waterways World had one in January this year. We're planning 3 articles, or Towpath Talk are planning 3 articles in the next few months on our work. You may or may not have seen Paul Rogers on BBC's Countryfile on April the 11th on the electric narrowboat Rowan. Wasn't a very long piece, but it was still a very useful piece, and certainly the team put a lot of work into getting that set up and the right things done. If you visited Virtual Crick this year, you might have seen the IWA Greener Boating leaflet, and you might also have seen these mug shots, question and answers with the experts, talking about green boating and how boaters can be more sustainable. And one thing, I've been modifying this presentation ever since I first put it together because things are happening so fast. Automarine in Worcester are doing some performance trials on the 29th of May. And they're going to take some boats from Worcester up the Severn, up here, onto the Droitwich Canal. And they're going to take them into Droitwich, about an 8-hour cruise. And their objective there is to compare the performance of different types of boats. And we haven't seen the detail of this yet, but there's some nice pictures of where they're going. And taking part in those trials will be a serial hybrid electric boat, Old Nick. Most of these have been built by Automarine, to be fair, so they have an interest in this. Perseverance is another hybrid of a slightly different design, newer in fact. Hunky Dory, another hybrid, again with slightly different components in it, slightly different technology. There's a parallel hybrid having the type of engine which I showed you earlier, which is also going to take part, and a conventional diesel boat. And I think hot off the press, Jonathan will no doubt tell us later, some of these are going to, at least some of these, are going to be powered by HVO on this trip. The press, the CRT, and ourselves have been invited, so we hope we'll be able to get along and see what happens. So there goes, guys. There's my presentation. We were founded in 1946 to preserve the waterways, and we're still doing it. And I think this is probably as important a piece of work as the work that was done by the IWA when it was first founded, which saved the waterways from a beaching type fate. Well, our job is to save the waterways from a lack of fossil fuels. So thank you, guys. I'm happy to take questions. If anybody has any.
We've got 3 questions in the Q&A box.
Okay.
Can you see them?
No, can you read? It'd be handy when you read them out.
Okay. The first one then is from Andrew Shipman. Why use any percentage of biodiesel? It doesn't seem fit for purpose. Can it be right that it can cause expensive failures in fuel injection systems? It gums up expensive fuel injection equipment, has a lower cetane rating, and doesn't burn clean. And I have, he says, saying he's got first-hand experience of its use in agriculture.
I think this is one for Jonathan.
Yeah, I'll pick that one, certainly. I came to this because I've been running my own vehicles on first generation biofuel for about 17 years now. Again, with altruistic desire to protect the planet. I've met all the highs and all the lows of FAME type first generation biodiesel. And it's a case of horses for courses, really. If you're turning the fuel over quickly, in other words, stick it in the tank, burn it, fill your tank up again, which applies to most of its uses, there isn't a problem. If you leave it sitting around, which you do in boats, in generator sets, and farmers are the worst culprits of all, and I speak as an ex-farmer. They store their fuel in an even worse way than boaters do. Then you're bringing out the worst in the fuel. It sits around. We've got the dropouts of saponification and a lot of much more complex chemistry than that, before Malcolm corrects me. The glycerin that Bowman referred to, that's what's doing the damage to pumps, injectors, and Ebishbasha stoves as well, it appears, talking to my local Ebishbasha dealer. Then there's a real problem. So it's fit for purpose if you use it in a road vehicle. It's not fit for purpose in the marine environment whatsoever.
Okay. The next question from Ian Wright. Can you mix HVO and mineral diesel in the boat tank?
Yeah, it's 100% miscible. In other words, it will mix with anything. So you can top your tank up that might be half full of mineral diesel with HVO or vice versa. Mix it up in any proportions you like.
Okay, thanks for that. Got a question from David Pullen. In view of the significant increase in energy cropping that has already happened, i.e. forage maize grown for anaerobic digester plants, why do you believe that it will be a problem in the future? Surely if it pays to grow energy crops, it will happen anyway.
Well, this is a very, I mean, this is a social problem that the world has to face. We have a limited amount of land to grow food on, and we have a very large number of people that need to be fed. If you're going to use that land to grow vegetable oils to make fuel, then you can't use it to grow food. It's a moral question. I'm not saying I've got the solution, I haven't. But we've got to balance the requirement for food in the world with the requirement for fuel in the world, and they're both big. You can get round it in a number of ways. HVO is currently manufactured, I think, almost entirely, certainly certified as manufactured entirely from waste vegetable oils. As the demand for it increases, we're going to run out of waste vegetable oils, and people are going to start to look to use other oils, which are going to come from various places. So it's a very, very difficult moral question.
Okay, this might be a bit simpler. From Nick Hindle, would new electric boats benefit from being lightweight, non-steel hulls?
Malcolm, I think, for that one.
I think I can pick that one up. The answer is quite definitively no. The benefits you derive from having a large propeller vastly outweigh the additional drag of the deeper hull needed to take it. I think it's probably true to say that our boat on a 30-inch draft is probably the most efficient of all the electric boats around the system at the moment. And the newer ones, which seem to be being built by people like Otter Marine, which are being built on shallower drafts, more akin to what Bowman's got, are using higher speed motors and smaller props. And while I haven't actually seen any figures, I'm 99% sure they will be less efficient than ours.
Okay, thank you for that. This is Michael asking, how is the problem of heating, especially liverboards, being tackled? I realise HVO is a step in the right direction, but it's not a long-term solution by the sounds of it.
I'll pick that up as it's HVO related.
Yep, please do, John.
So I live on an all diesel boat, so it's not a problem. Part of the trial I've been conducting with heating and cooking devices over the winter has included my Dickinson stove. Put 200 litres through that, and it burns even more cleanly with less deposits than ultra low sulfur diesel. So it's either going to be an all diesel boat, which I can tell you from 22 years experience is very realistic, very practical. Or I think that as we move in the direction of serial hybrids of any sort, it's going to probably be electric heating, but maybe Malcolm would like to comment on that.
Yeah, I'll come in on that. First of all, I'll second what Jonathan said about the clean burning of HVO. We're using it through our Cabola, and it's much cleaner than the red diesel we used to use. The answer to the problem is almost certainly something which hasn't had a mention yet, and that's the heat pump. We hear quite a bit about heat pumps being used in domestic situations, and these are usually either air source or ground source. But what is ignored is the fact that the most efficient of all heat pumps are water source. The oldest installation of which I'm aware is in the Royal Festival Hall in London, where the heat is taken out of the Thames. But there's a good chance that you could get something like 120, 130% efficient use of energy put through a generator, the energy in diesel fuel put through a generator, if you then use that electricity to power a heat pump.
I mean, ultimately, if you've got an electric boat, then your heating and other domestic requirements have got to be electric. The only real issue is where do you get the electricity from?
Okay. The next question, Jeff Ward is saying, thank you for the presentation. What limitations will there be in trying to shoehorn systems into small narrow boats? You know, thinking of 30 foot or less.
Yeah. Well, I mean, obviously a narrowboat in many ways is an ideal craft to put in systems, because the bigger boats, the sort of boat I've got, and there's, compared with a car or something like that, there's plenty of space. I mean, Malcolm has quite a lot of traction batteries on his boat, and he's found space for them. Now, obviously, as the boat gets smaller, that problem gets more difficult. There's no doubt about that. And maybe once you get to a very small boat, then you simply make do with the battery. But I don't know, Malcolm, have you got any thoughts on that?
Yes, again, I think the key to this could be the arrival of fuel cells. I mean, we have an 8 kVA genset, which we run for a few hours a day, and then we run off batteries for the rest of the day and maybe the day after. But if you have a fuel cell, which basically needs to be run continuously, a very small fuel cell, probably less than 1 kilowatt in rating, running 24/7, is more than enough to power a narrowboat. And because it's running continuously, you don't need a battery bank that's anything like the size of ours. So I think between having a fuel cell and probably using lithium batteries, which give you a higher power density anyway, you would manage perfectly well on a smaller boat.
I think the moral of that story is, if you think back to motor vehicles and look at what a motor car looked like in, I don't know, 1920, and compare it with a modern motor car, you can see that technology moves on and allows us to do things that we thought were impossible a few years ago.
Okay. Next question, Russell Morehouse is asking if there's any government or other targets for banning new diesel powered boats.
Well, in theory, diesel engines can't be sold after 2030, is it?
Yep.
So I can imagine that might be a line that we cannot cross, and that obviously won't apply to the existing fleet. I can't see that being banned any more than it's going to happen on the roads, but it's quite likely that building a new diesel boat after 2030 may well be impossible.
Okay, I'm going to skip a couple of questions now if I think that they've already been answered. There's one from Robert Almquist, hopefully I pronounced that correctly, saying, considering the number of powered boats in the UK compared with the number of powered road vehicles, how high a national priority should achieving sustainable boating really be?
Well, the answer is it's not a high priority and hasn't been a high priority for that very reason, that we are relatively small users of fossil fuels. We're a very relatively small contributor to the national problem, which is why it hasn't been a high priority. But eventually, when everything else becomes more environmentally friendly, it will become a higher priority. And we have to recognize two things, I think. One is that will eventually become a political priority, because people are going to say, well, I'm not allowed to use a petrol or a diesel car, but why can all these idiots go around the canal system using these smelly old diesel engines when I'm not allowed to use it? So it starts to become a political problem. And it's also a moral problem. I mean, you know, why should we be allowed to use diesels and pollute the planet, even though what we're doing may not be as big as, say, road cars? So, yeah, it is a low priority, has been a low priority up to now. But by the way, the government are starting to look at it now, and not because we've been winding things up. I mean, they are looking at it not only for inland waterways, but they're looking at it for coastal shipping and for larger scale shipping as well.
I mean, can I throw in a bit of reassurance there? Basically, Department for Transport has for some while been looking at all sectors that burn hydrocarbon fuels, appreciating there's a finite amount of feedstock for HVO, encouraging the development of a lot of other technologies, non-organic fuels, and then looking at which sectors are best served by which of the fuels that are either available or will be available. And they've gone about it in really quite a scientific way, and a lot of thought has gone into it. And the work that I've seen, it's very much ongoing. It's our consultation on the RTFOs is a part of that work, a very small part of it. But there is a global strategy. There is a plan looking at the big picture. And it does take account, for instance, of the finite amount of feedstock that will be for organic biofuels. And at the same time, it's encouraging the development of a whole range of very sophisticated inorganic biofuels. So it's, you know, just by way of reassurance, there is a grand plan. Whether you rate our lords and masters highly or not so highly, I'll leave to you to decide.
And I would also have to say that because we've got the vision that we've got, and it looks to be reasonably practical, although it may get changed by technology and time. But what it means is that we are able, I think, and Jonathan, I think, has already proven this to some extent, we're able to influence the way in which government moves, that in ways that hopefully will suit the inland waterways. Whereas if we were just had our heads buried in the sand, we'd suddenly find we got something imposed on us that maybe didn't suit us.
Okay, the next question is quite technical. So this is Demetrius Theologitis. Could you please give an explanation why a standard diesel for a 57-foot boat is 43 horsepower, and then a serial hybrid pretends that 10 kilowatt, 13.5 horsepower, I think he means, is enough for a similar boat? The issue of torque has nothing to do from an engineering point of view. It's not about acceleration, but of pure propeller revolutions.
Sounds like one for Malcolm.
Lovely one.
Did you get that, Malcolm?
Yet another engineer fooling himself. The fundamental problem,
That's coming from a chemist, so be careful, everybody.
but it is coming from a chemist who's designed and built a boat that works. It is fundamentally down to propeller efficiency. I can go through a huge story, but essentially a diesel engine starts with low torque, goes through a higher phase and then falls off again, where an electric motor has a higher figure anyway across the piece. But given that a diesel has to start its propeller more or less instantaneously when you pop it into gear, it actually needs a huge amount of torque, which it doesn't have. So you have to put a much bigger engine in to overcome that barrier. And then because of the speed that you're getting through your reduction box, you have to put a relatively small propeller on, which again is inefficient. I come back to the point I made originally, that the bigger the propeller and the slower it turns, the more efficient your boat will be. And an electric motor can do that a lot better than a diesel.
And I think the other factor in there, which I think Malcolm alluded to earlier, but we just perhaps reinforce, my 2-litre diesel engine, if I want to accelerate my boat away or to brake it, I have to use maybe not 43 horsepower, but I have to use a good chunk of the power I've got, and therefore I need an engine of that size. But on the other hand, in Malcolm's boat, he gets that power from the battery. So if he needs to put a lot of power into the prop, he pulls it out the battery. He can run a very small generator, as he says, 24/7 if he wants to. And as long as he's keeping the battery fairly well topped up, then if he needs a squirt of power, he can get out the battery. He doesn't need a big engine. Is that fair, Malcolm?
Yeah, totally fair. But again, we come back to the point, I just literally yesterday found some figures from some trials I did with our boat while it was in Ireland. And we actually need 1.7 kilowatts to maintain 3 miles an hour in open water. Now that would be unbelievably low for a diesel powered boat. And that's all down to prop speed and size.
Thank you. It's not a question, but someone's making a comment that that people can't see the questions, and that's a feature of Zoom that the other panelists don't seem to be able to see the questions either, so I apologise for that. We are running a bit over time now, and we do have a few questions left, which I don't think will be short answers. So is it okay if are you happy, Bowman, Jonathan, Malcolm, if I get the questions sent to you and if you would answer them, and I will
No problem.
send them to participants. So show my face again now. So I apologise if your question wasn't answered, but we will get around to it in another form. So I want to say thank you very much to Bowman, Malcolm and Jonathan for that. It's a really interesting talk. Lots of questions, lots of interest, and what I'm thinking now is we need another talk on this subject, because it's going to get bigger and more important and more relevant to people. So when I'm drawing up my next social calendar, then I'll be coming to you to come and talk to us again. I'm sure there's a lot more to say. So thank you.
You're very welcome, and of course things will change. We will not have got everything right.
Thank you very much to our speaker and to Jonathan and Malcolm for joining in. I'm getting lots of thank yous and well done and great presentation messages up as I'm speaking. So I'll say good night. Take care, everybody, and let's hope we all have a good summer and we can get out and about. And thank you very much, and hopefully we'll be able to see you soon. Goodbye.